I'm Christian Rodriguez from the Wolfram Foundation, and my talk, Computational Thinking in the Classroom, focuses on how an educator can integrate computational thinking into their already developed curriculum. Good morning, everyone. Thank you for joining us this morning, especially on this final day of Tech Conference talks. So, I'm Christian Rodriguez. I am on behalf of the Wolfram Foundation, and today I'll be talking about some examples and instances of computational thinking in the classroom. So essentially, what today, as you're all aware, or throughout this conference, computational thinking has been sort of a topic of discussion. We realize that there's a critical need for teaching and learning of this. We place a heavy emphasis on the student outcome and what's in it for the students and what's going to be the value for them and for their future. But in this process, we're not really talking about the educators themselves. That we have a public education system that's a little bit far behind and is not up to speed to regards to a new skill like computational thinking. So in order to address this sort of momentous challenge, what do we need to do? Because we are well aware that educators are already time-strapped. They don't necessarily have all the resources they need, and they may not even have the skills required to teach something, but they have the motivations, the ambitions, and so on to do so. So how can we address this? But before I get into all those little fun, dirty details, basically, why am I here? So this will be my third participation at the Wolfram Tech Conference. I have nearly been at Wolfram for 4 years. Wow, okay, time goes on fast. And within this last year, I've partaken in this role as the project manager for the computational thinking initiatives. So what this really means is that I've overseen the on-the-ground efforts and the strategic outreach for all of the AI League programs and various computational thinking outreach. Before then, I was part of the greater Wolfram research and helped develop the student ambassador and community ambassador programs. As I look across the room, I've actually had some contact with some of you before during those different programs, so hi, familiar faces. And to even get before that, I've always had this interest in education, specifically STEM education, access, and equity. During my college years, I went to the University of Illinois. I was a researcher at the Child Development Lab focusing on neurocognitive testing. So essentially, what sort of testing mechanisms bring greatest alertness and awareness to students and what essentially creates cohesion and memory, adaptability. And then throughout that same time, I was also a technical writer at Turn, which was a digital advertising startup, which was purchased by Amobi, then purchased by Singtel, which some of you may be aware of. And when I tell people that I graduated from the University of Illinois with a degree in advertising, they sort of get this look of bewilderment, like, okay, then why am I talking to you? Naturally so, why, right? And it's essentially that these extended learning experiences and circumstances have essentially shifted my entire career focus, where now I find myself in this technical role, and I even consider myself a bit of an example of where computational thinking can take your career. So whenever I talk to students, I tell them, let me tell you my story and why I think this is relevant, and let me tell you about the trajectory you can potentially find yourselves in. And before I even get going with the rest of these things, let me say that I'm not a curriculum expert, nor am I a teacher. But I am someone that has had informed experiences, and I am one that has been in the classroom, dozens of classrooms, has worked with hundreds of teachers and hundreds of students, and that has given me an ability to basically understand what are these needs and what I can provide based on the resources the foundation has, Wolfram has, and this incredible network of enthusiasts and evangelists have. So with those, I'll carry on. So as I said, we have this challenge of preparing educators to teach computational thinking. For many educators, this is a discipline that's sort of very new to them. Either they weren't taught this and during their upbringing, or it's simply they don't know how to teach it. So how do we sort of address this gap? And according with that, to better prepare educators for this, we realize that we need to understand that they need time, resources, a network of peers to support them, and as well as essentially the support to help them, guide them in this process. So the observation of these needs prompted myself and us at CTI to add a new focus to the initiative. And that's essentially teacher training. So CTI initially focused on extracurricular programs for middle school and high school students. We were like, it is too hard to get into the classroom. It is too hard to change institutions. So let's settle with tackling this beast some other time. Let's make sure that we can provide teachers with the resources that they might need so that they can do this. But after having several conversations with educators and individuals who are truly motivated about bringing this to the classroom, we realized that, okay, maybe there is something that we can do. So with that, we decided to start dipping into what some of these teacher training tools and teacher resources might look like. And our very first instance into this were our educator roundtables. Some of you participated in these, but some of the main topics we covered were computational essays as an assessment. Now, we've started to hear this term, computational essays, a lot throughout this conference, and some of you might still not have an entire clue about what that might be. I think Stephen purposely leaves it as a sort of very generic thing because he wants the individual, the writer, to sort of craft this narrative, this exposition. So how do we use essentially this writing tool as a way to understand someone's comprehension and proficiency of computational thinking? So that was the very first roundtable we hosted. Then we addressed how can we write a computational thinking lesson plan. To some of you, this might be an AI adventure, but to the general educator masses, the best term to use is computational thinking lesson plan, because it has a structured approach where we identify the objectives, the goals, what the students need to learn, and how they can go on off path of what's already available. Then we decided to provide essentially the training where if someone wants to run these activities on their own, they can go ahead and do that, but they just need a little bit more guidance, a little bit more confidence. So that's when we hosted the Running an Adventure, and that was one of our CTI ambassadors led that discussion himself, as he is someone that has ran several of those. I will add that these are all recorded, and I can make available to everyone so that you can understand exactly what is our interpretation of a computational essay and how they use it as an assessment, how you can go about writing a computational thinking lesson plan, and how you can run one yourself. So the next step to sort of addressing these needs of educators, we decided to look into developing a course, focused on kind of bringing these elements of these different CT principles and essentially what teachers need in their curriculum to fulfill the guides, restrictions that their school presents to them. So with the support of Russell Folt-Smith, he is the co-founder of the Acton Academy in Venice Beach, which is essentially a school devoted entirely to project-based learning and student-centered learning and computational thinking. So with him having this guidance, we were able to spearhead what the content of this course is and what we would be able to deliver to these participants. And to go into a little bit more in depth about who were these participants, none of them had any Wolfram language experience. They all said, I care about my students. I want to be able to provide a learning experience from that will impact and matter to them. and I know that computational thinking is going to be one of those skills that's going to be relevant to their lives. So what can I do, and how can I be supported? So we decided to build this course around five outcomes. So first and foremost, since we will be using the Wolfram language, we had to be able to provide, or at least get them through a point where they were proficient in the Wolfram language, so that they themselves could then go into their classrooms and teach their students. Now you might think, what are we going to be doing to teach them that? And perhaps the best way to do that was through EIWL, and which most of you are all aware by this point. But that itself is not the best thing to do, we soon realized. Because no one really wants to learn out of a textbook entirely. You know, you want to work off of it, you want to dive into your own path, you want to understand kind of how you can play around with the different complexities of it. The following thing is we had them craft their own definition of computational thinking. For them to be able to understand what this is, to be able to articulate their own definition, and for them to be able to basically explain this and teach this to their class of students. Then we had them create their own computational thinking lesson plan so that they knew how to essentially begin to integrate their own lessons into their already developed curriculum, as well as how to be able to run their own adventure log. So in order to sort of assess how they were going to do this, they submitted a proposal about how they were going to follow up on this, on what they learned, and how they were going to essentially act on that, whether it was through getting through the approval of administration, it was getting the approval of a curriculum director. How would they go about ensuring that what they learned was actually put to use? And to talk a little bit more about some of the themes, we addressed first and foremost, what is computational thinking? As most of you are well aware, there are several definitions that exist out there. And there's a lot of resources out there that might seem a little bit overwhelming at times. So how do we identify a participant's own mission with their students and with what we're doing versus what everyone else is doing? As well as, what does it mean to craft a computational thinking lesson plan? I think our AI adventures do a pretty great job at providing a structure for students to be able to understand the different components and principles of computational thinking, and as well as a more specific topic of computational X. So we had a forensic science teacher, we had an earth science teacher, we had a finance banker, and a few other individuals that just taught completely different topics. So the point was, how do we add computation as a tool to your course without having to change the course entirely? So we had them work on exercises. This was about halfway through the course itself. And we said, all right, let's use your own curriculum that you already have. And what snippets can you add programming as a tool? And from then on, it was actually a pretty neat exercise because the teachers themselves, for the first time, got to see what it was to engage themselves in that deep computational thinking process. Like, okay, I can use Wolfram Alpha as my data repository. I can use Wolfram Alpha to pull in all these historical or food data. And what essentially ended up happening was that this 1.5-hour class ended up becoming 3 hours because they were just working with each other, doing some pair programming tactics, and really like one-upping, helping each other out, making sure that they essentially created something out of this. If you guys aren't aware of computational X, it's essentially a concept that every academic, every professional field is going to have some component of computational added to it. And we're well into that curve already. Then considering that we're dealing with educators, a lot of times we have to consider is whether they have the right motivations, whether they have the passion to essentially address this issue in their classroom and make this change. So what we ended up doing was practicing some self-efficacy exercises where we had the educators write down their goals, why they think this is important, and where they see this fit and how they want to impact their student lives. Basically to get a clear understanding that this is something that they were deeply interested in and wanted to work on. And moving on with that, it was structuring a program. Basically, if you can't integrate this into your curriculum, what can you do? What else can you do? And what are those components of a program that are going to be required? Logistical details, program details, and content-wise. And the most important part was integrating computational thinking into their curriculum. And by that part, it was specifically, perhaps the most important thing was to take a look at the computational thinking principles themselves as the guiding tool for this integration. When we look at curriculum itself, teachers have already spent X amount of hours doing it. They're not going to want to completely write something from scratch, and they're not going to want to essentially bring in something that's not going to excite their students or their students are not going to care anything about. So with this, we asked them to identify certain parts in their curriculum that they could relate one principle to. And from then on, one of our educators is a social studies teacher. I can go up. Oh. And she decided to use the interpreting a problem in a way that a computer can assist with it, and using data to address real-world situations for most of her integration. So for her social studies course, students had to compare their modern lifestyle with the lifestyles of children from another era. So you think, what does this even mean? And why is this even question asked? So essentially, they had to simulate the experience of another child. Essentially, they picked someone from, let's say, 1800s Australian civilization, and they had to label out exactly what were their predicaments and what were their lives. And then they compared it to their own lives and tried to simulate the differences between how has life greatly changed. Students also reviewed data to identify patterns and trends in wars and other historical events. I think the go-to strategy, or I guess problem and project with this specific assignment, is that people want to go directly to Google and search things up. They want to say, what happened during this battle, how many people died during this battle, and what were the repercussions of it. And you don't realize you can do this all in the notebook. You can literally pull the information right in there, and students can really evaluate themselves and essentially build simulations to reveal the findings. Students create a simulation to study relationships and social science phenomena such as women's education and health. During our, during our own educator course, we had students, our participants, engage in a group adventure, which essentially we had them address the issue of maximum carrying capacity for the Earth. So essentially they had to bring in all these different variables and figure out how they can essentially address this challenge or solve this issue. And essentially that's what she had her students do. She used the group activity from our course and brought it back to her classroom and actually implemented it. And she saw, it was actually really nice to see, because she said, I finally saw my actual skills being put to use. I learned something and I immediately saw it being put to use, and my students loved it. And then another more prominent one is students use primary source data to study the voting pattern, or the patterns of voting rights in the nation. I think it was Seth Chandler who wrote a community post about how we can analyze voting trends. She essentially ended up using that blog post to lead the lesson for that day. And I can share with you guys essentially what these student projects looks like, because they were all asked the same question, but they all came up with different visualizations of it. And that can kind of give you an idea of how each student approaches computational thinking differently. So the important thing here is to focus on not trying to build a whole new course on computational thinking, especially if you're new to this or you're new to programming in a Wolfram language, but to understand how you can use this concept itself, break into pieces, and use those pieces to make slight changes to your curriculum where you can help students understand what they're doing and why this is necessary. So a lot of times, just these concepts are what can guide students directly into these lessons, into these activities, and for them to start getting to this path where they're well aware of what it means to be computational thinking, what it means to break down a problem, what it means to implement these questions, and so on. So I think I need question time.